what is the distance traveled by the bat in the time interval 10 seconds to 40 seconds. So the graph which we are looking at over here is velocity time graph. So with this, to be specific, it is displacement that we are finding. To be honest, with this graph, displacement and distance would be the same. But anyways, I want to be very specific about what you're finding when you're working with velocity time graph, and that is displacement. So we're looking at finding the displacement of the bat during the time interval 10 to 40. So the units are meter per second, and we have this in seconds. So 10 seconds is right and 40 seconds is right. Now, to find the distance or displacement in this case, we need to project 10 seconds and 40 seconds onto the graph where the graph meets the axis, not axis, sorry, the graph, where the point meets the graph, something like this. 40 meets the graph over here, right? All this line is extra bit, not required. And this point projecting onto the graph, here we are projecting the point onto the graph. We used to project a point onto the axis, right? Here we're projecting onto a graph, and that would intersect over there. And we would also need the projection of these 2 points onto your x-axis, and that turns out to be the same point, that is 6. So basically, to find the displacement, we need to find this area and this area. Okay, so basically this entire area is what we need to find. First, let's find out AB, CD, and then find out AD, EF. Right, so this is a trapezium and this is a rectangle. So finding the area of a rectangle is not a big deal. Trapezium is a bit tricky to you guys, I know that. Anyways, but yes, this would be at least 3 marker question, so it would be worth your time. And anyways, conceptually also, this is very good. You'll be understanding a lot of concept, the concept of how to handle units and how things can be derived from units itself. There are quite a few things that you will be studying in the future, but you kind of get introduced to it over here. Okay, so let's first figure out the area of trapezium. This is a line which is parallel to the other line, and the distance between them would be something like this. So we'll call it as P. That would be perpendicular to the other parallel side. So we need to basically find the length of BC, AD, and BP. So these are the 3 values that we need to find the area of the trapezium. And later on, we'll find the area of the rectangle. Okay, so let's begin by finding the area of the trapezium. Again, we're trying to find the distance displacement by finding the area under the graph. So this is the area under the graph. Under the graph mean between the geometrical structure and, that is the slope, the slopes, the graph, and the x-axis. So please understand that this entire region is something that we need to find, and all this projection and everything, including the projection over here, would be helping us to find that. Okay, so let's begin by finding the length of, we'll find from top, we'll start BC. So let's find BC. BC is nothing but it's a line parallel to x-axis. So basically we need to project B and C onto the x-axis and see where they intersect. B intersects at 20 and C intersects at 35. So basically this is CX minus BX. So CX turns out to be 35 and BX 20. And this difference is 15 and the unit is in seconds. Now, next thing is we need to find AD. We'll go in a systematic way. First, we'll find the parallel side's length and then the perpendicular length. AD is projection of D onto the x-axis minus A onto the x-axis. D and A. That is 40 minus 10, and this would be 30, and the unit is second. All whatever is the unit over here, all that you have to do is copy it onto the answer. That's it. Okay. Don't think too much. Just copy it. And then we'll find BP. So BP is projection of B and P onto the y-axis because this is parallel to y-axis. So we are looking at BY minus PY. So BY is 10, PY is 6, and the difference is 4. Unit is meter per second. And then we have, that's it. So area of ABCD is equal to half into sum of parallel sides into the height. So half into parallel sides are BC plus AD into the height is BP. So this would be half into BC. BC is 15. AD is 30. So these are measured in seconds, by the way. BP is 4 meter per second. And now we just have cancellation, 45. And this is 2. 45 into 2 is 90. So the area in this region is 90. And the unit turns out to be obviously meters. Now we have to find the area of ADEF, and that sum of all of this would give us the displacement. So some people might just end up finding this. That's not the complete answer. We need to find the area of this entire thing. Okay. Remember, it is the region bounded between the x-axis and the graph. So let's find ADEF. So before that, I need to make few changes. Okay, changes done. I didn't have space over here actually. That was the cause of the delay. For you guys, it's not a delay. For me, it was a delay. Now, area of ADEF would be length into breadth. So what is the length over here? Length would be, say, AD, if not FE. That would be easier. FE into the breadth is, say, AF. Now, all we have to do is find, actually, we need to find FE or EF. So EF is this. So basically, it's a line on the x-axis. So basically, EX minus FX is what we need to find. So EX is 40, FX is 10, and the difference is 30, and the unit is second. Next is AF. AF is projection of A. It's a line parallel to y-axis. So the projection of A onto the y-axis minus F onto the y-axis. So A onto the y-axis is 6 minus 0. That is 6 seconds. And we have both the values. All we have to do is, sorry, this is not second, meter per second. And all we have to do now is area of ADEF would be equal to 30 into 6. Let me write with the unit so that you guys get the concept. 30 seconds into 6 meter per second. And we have second and second getting cancelled. And this is 180 meters. Sorry, not second, meters. So all we have to do now is add them up. So the area total, or total area, would be equal to area of trapezium ABCD. I hope I'm right about that. And area of ADEF. This is 90. It's over here itself. Plus this is 180. So both are in meters. We can add things with the same unit. Actually, we can add only things with the same unit. This is 270 meters. And that's the distance traveled by the bat during the time interval. The displacement of the bat between the time interval. What's the time interval? 10 second to, I think, 40. Yeah, 40 second is 270 meter. So that is your answer. I hope you guys understood the concept. If I've done some silly mistake, I think I didn't, but if by chance if I missed out some decimal, not decimal, I mistook some point, you guys can correct that, right? I hope I didn't make a mistake. This is your answer. Very simple. The area under the graph, under velocity time graph, will give you the displacement.